Okay. Hi, everyone. Welcome. In this video, we're going to be talking about time series econometrics with explanatory variables. So up to this point, we have been estimating time series models where we use past values of a variable to explain itself in the current time period. So as you noticed, uh, it doesn't really do a sufficient job. Remember that I asked you to think about what might cause a stock price to go up or down? Everyone said that it's due to some other factor, right? So our model of a stock prices should reflect that concept, should reflect that belief that other variables have an impact. And so we're going to talk about that in this video. So next, before we go, so let's get started, right? Uh, For this portion of the lecture, we'll be dealing with distributed lag models. So basically, a time series model where you have an additional explanatory variable, and these could take on different. Sorry. So these could have different lag values depending on your choice, your theory, or whatever. And in this video, we'll also talk about spurious. Uh, Not in this video, sorry, in this lecture which is going to consist of a few videos. In this lecture, we'll talk about spurious regression as well, which is kind of the underlying concept when we talk about correctly estimating time series models. It's always about trying to avoid spurious regression. We'll talk about what that means. After this lecture, uh, you would be able to grasp the importance of stationarity as a concept, how to test for it, and how to correct for violations. Finally, you want to be able to differentiate between root processes, trend stationary, and different stationary processes. Okay, so let's get into it. Okay. As I mentioned, oftentimes past values of a variable does not sufficiently explain its current value. For example, e.g., right? E.g. means for example. For example, stock price depends on several factors other than past values. You mentioned the U.S. elections. We will mention demand for uh, computing power, etc. Right? So these are all external to the stock price. So a more accurate model should include effects from other explanatory variables to improve model prediction and understand causality. Right? Model prediction, we're talking about the y hat, right? True y, and we have the y with the hat. That's the model prediction. It's equal to the linear equation of x and betas. Right? X is the explanatory variable, and beta is the coefficient. Causality, okay? Understanding causality, we're looking at this beta j coefficient. And think back on the regression equation, right? We want to improve model prediction by including all the relevant factors. Hence, sorry about that. Hence the additional variables. And then we also want to be able to understand causality in that we want to specify our model correctly, avoiding spurious regression. Okay. To do that, we start with explaining what we call the distributed lag model, a model where lag values of explanatory variables explain the dependent variable. Okay, what are we talking about here? It takes its form, right? It takes its form. So YT, the time series that we are interested in, is a function of beta 0, right, plus beta 1 xt plus beta 2 xt minus 1, lag 2, and then lag all the way to k. Uh, and then epsilon t is the error. Notice that yt is being explained by xt, right, as well as the lag values of xt. That's why we call this a distributed lag model. We can use this for impact evaluation. Something happened to X, what happens to Y? What happens to Y next period? What happens to Y 2 periods after that? You know, e.g., again, e.g. means for example. For example, effect of an interest rate change on domestic investment. There can be more than just one explanatory variable with different lag lengths. That's the one thing to remember. You might have x1, x2, right? And each x is going to have its own length of lags depending on your theory or your statistical test or whatever. Okay. All right. Now, we still don't forget about the AR model, right? So we can combine the DL distributed lag structure to what we already know about the autoregressive structure of your time series, right? So in this case, AR DL model is a combination of AR and DL, right? So if you look at the equation here, this is the generic model, right? Don't get scared with all the notations. You'll learn this in this video. Okay, YT equals alpha, which is the intercept, plus this thing. Okay, let me explain to you what that means. So you see, sigma means the sum. The sum of what? If you need see this I here is the I that appears over here and over here as well. So the I subscript talks shows the that the this here is the sum of phi I, right? Y minus yt minus I, starting from 1 all the way to p. So for example, let's say you have p equals 2. You're going to have phi 1 yt minus 1 plus phi 2 yt minus 2 plus phi 3 pi yt minus 3. That's the sum. Okay? So you're just replacing the I here with the number from 1, 2, 3, 4, all the way to p. Add them all up. And so instead of writing the long summation, we condense it so that we can save space. Okay? So this part is known as the autoregressive part of the model because it is using yt in the past, t minus I here, 1, 2, 3, 4, all the way to p, right? Y past y to explain current y. So this is the AR, autoregressive portion, okay? And then it's going to add, plus it's going to add the distributed lag part as well. In this case, we're just showing one x variable, right? But with lag length all the way to q, right? So it starts from j equals 0, which means the current xt. And then j to 1 is t minus 1, j2, t minus 2. Each lag is going to have its own coefficient, beta j, right? Corresponding to the number of lags. Beta 0 xt is the coefficient on the current xt and so on. Okay, so we can have this kind of model as well. Okay, so that's just a quick introduction, right, into what the model would look like. Now, in the next video of this lecture, we will talk about what are some things to be concerned with when we estimate these models. Of course, you know, computationally, all you have to do is add variables. Right? Let me show you really quick here. Right? So in this case, I'll show you later in the next video, I guess. But in this case, all we have to do is to go ahead and don't worry about that one. All you have to do is go ahead and just estimate. Right? For example, uh, let's say my x is let's say my y is price, right? T is equal to uh, some kind of function f of lag price as well as open, right? In this case, the lag price would be the AR portion of the model, and open would be my DL. Okay, so how would I estimate that? Just do linear regression. Regress price on L dot price, right? In this case, lag 1, I guess. And I'll do open, which is the x variable current as well as the lag x1 period. Okay, so y variable, autoregressive, x, there's x, and there's the lag x. So this part is the distributed lag part, and this part is the autoregressive part. Estimate the equation, and you get something that looks familiar, right? The coefficients, statistical significance, right? So yeah. Anyway, so I'll stop the video here and I'll start the next video to go further into talking about what we should be concerned with when estimating these models. So computationally, we already have all the tools. Okay, so go ahead and stop.